So looking at our skeletal model, looking at the lesser heads, we're talking about 2, 3, 4 and 5. There's a number of ways that we're looking at the joint movement, and we're looking at mainly sort of dorsiflexion. That's our main area of interest, where we're looking at the movement of the digit in an upward direction, both range and quality, as with any joint. But it's also important to look at the excursion. The excursion basically meaning almost this sort of piano type effect, and that's really looking at the quality of range in an upward and downward direction, getting a feel more so for how the foot in the forefoot will adapt to the different terrain demands that it's placed upon. It's also important to quantify that. So the final structure that we're interested in is the lesser metatarsals, so 2, 3, 4 and 5. We're looking for their range in a number of directions. We're looking at first at their extension into dorsiflexion, so second, third, fourth and fifth. And also looking at their excursion in a dorsiflexion and plantarflexion position, so we're looking at the ability to move up and down. And what we tend to find is that the fourth and fifth tend to be a little bit more loose than the second and third. We're looking for this piano type effect, where the metatarsals themselves can move in response to the loading and the terrain that they're on. Looking at the overall structural profile of the forefoot, what we're looking at in this instance is the relative positions of the metatarsals 1 to 5, and that's relative to each other. And what we can see in this instance is that we've got a marginally plantarflexed first ray. You can see as we drop down the dip effect that we have around the plantar surface of the first metatarsal itself. And also as we move across the foot, you can see also that the fifth is also in a relatively plantarflexed position relative to the fourth. So what we know about this foot in regard to the ground reaction force is that the first and fifth will be taking most of the load for longer because of this structural profile. So it's important to look at the metatarsals relative to each other in their resting state.